Okay, it's around 1 o'clock, so I guess we'll get started. Welcome, my name's Bill Horvath. The title of the presentation is Secrets to the Swarm. We're here to talk about Docker secrets and how you can leverage them to have a more secure development environment right off the bat. A little bit about me. I'm a developer primarily. I work for Improving. We're a software consultancy that's based in Dallas. We have a Columbus office. That's one that I'm out of. We have 6 other offices across the US and Canada. And I also have a background as a Scrum Master and Agilist. My education was in industrial organizational psychology, and I like to do art and play with cats in spare time. So that's all you'd probably ever want to know about me. So why Docker? I don't know how much exposure you guys have to Docker, so I'm going to give you the whole story of how it evolved. Way back in the days of the moon landing, we had monolithic applications, right? These are applications that were unified software packages that offered lots of functionality. But as it turns out, there were side effects. Fixing one part of the program often meant breaking another part. There was often featureitis. Back in the days of when Microsoft Word was still being sold independently. I don't know if you still can get it independently, but I think it was when they got to the mail merges that things really started to get out of hand. So too many features made things too complicated. Delivery time to go from 0 to done was forever, and then by the time you got to the end of the project, often what you were building wasn't what the customer needed anyway because time had moved on. And of course, these monoliths required very expensive hardware on which to run, even after we invented VMs not too terribly long ago. So along came Ed Dykstra and Chris Reed, and they invented and popularized the concept of separation of concerns, where we are taking functional bits of software, that's what they meant by a concern, as a unit of functionality, and separating it out and programming it individually and having it talk to the other pieces. So there were lots of ways that this came to be implemented. It started with design patterns and interface-driven designs, APIs, microservices. These are all ways of separating the functionality within your applications. It was a bit like our form of government, in which we have separate legislative and executive and judicial branches that work highly effectively together. But it turned out that breaking monolithic applications into pieces was somewhat challenging. We still needed these applications to work together because they needed one another. Front ends need back ends, CRMs need databases, cats need humans, arguably, maybe not. And we could only run a limited number of applications per piece of hardware, even with VMs, because VMs are relatively computationally expensive to run, right? So, and then of course there was the problem of messaging between applications. It was a pretty ugly, particularly in the early days. Anybody remember Java EE 1.0 or Corba? If you've ever had to deal with those technologies, you know how messaging can be rather challenging. So, I don't remember off the top of my head. Did I write it down? No, I didn't. Finally, somebody realized. I'm gonna have to look this one up. But at not too distant past, somebody realized, what if we, instead of virtualizing the physical hardware, the bare metal, why don't we virtualize the OS and expose that? So, and not only that, my application doesn't necessarily need all the functionality built into the OS. I only need certain bits of it. And thus, we're inventing containers, which is a minimal OS and one or more applications put together in a file that can be run independently inside of a container management system. So, of course, now we need a tool to manage these things. And that's how we got to Docker. Okay, so what is Docker? How does it work? Docker is a unified solution for container creation and management. It allows you to build containers, deploy them into an environment, and have them running as units of functionality. Docker Engine is the application that's installed on a host machine. Okay, that's the core of the system. It's a daemon, and it exposes an API that listens to requests coming in that are getting forwarded to these containers. The containers are specified in Docker images, which are small plain text templates called Dockerfiles. They define what OS and what applications will be run in the container and what else needs to happen to that container to configure it. But they're usually very short and to the point. That's one of the actual appeals of the whole thing is it abstracts away a lot of the installation steps. Docker images are stored in a Docker registry. I'm sorry, a Docker repository, excuse me. And then repositories are stored in registries. So I don't have the registry concept on here, but we're not going to be using a registry today anyway. We're just going to be using a repository of local images. And then images are pulled from the repo and instantiated as containers by the Docker engine on the host machine. Okay, so what is a Dockerized application? So like I've said before, these containers aren't usually run in isolation. They're application components. They're bits of a larger application. So they're usually deployed in sets. And this is what I call them Dockerized applications. I don't know if there's a technical name for it. But so the individual application components are core units of functionality. They do things like managing access to a database, exposing an API, other things. Docker Engine can run a Dockerized application on a single host by instantiating each container on that host. And that's great, but what happens if you want to make it robust, if you want to span the system across several hosts? What if you want redundancy, you want load balancing? How do you operate more than one copy of a container running at the same time on more than one host? That's why Docker Swarm was invented. So Docker Swarm is a collection of Docker machines, which may be running on more than one host, okay? And the machines are what are instantiating the containers. Within a swarm, a Docker machine is either a manager or a worker. The managers basically tell the workers what to do, and the workers, both the workers and the managers, also functionally deploy containers and make them accessible to the outside world. So it's a cluster-based solution. It's kind of like Kubernetes. It's a little bit simpler. It comes built into Docker. I think Docker 19 includes Kubernetes now, if I'm not mistaken. So you can choose either Docker Swarm or Kubernetes. I'm not super familiar with Kubernetes yet, so I can't comment as intelligently about it, but I do know it can handle secrets in a way that's analogous or similar to Swarm that you'll see today. All right, so one of the things that distinguishes a Docker Swarm from a garden variety single Docker engine is when you add containers to a swarm, you add them as services, not just containers. So the swarm says, I'm going to spin up any arbitrary, you can tell it, spin up 5 copies of this container that are going to offer this service. And then it load balances across those for you, right? So that's functionally how a swarm differs just from a single Docker engine running on a single host. Okay, so that raises the question, of course, what's a secret? A secret is a named blob of data. It's stored in what's called the raft log, which is the logging system that the Docker machine uses. I have not actually yet looked into the technical details of the raft log myself beyond knowing that it's encrypted, which is the part that I cared about at the time. So for example, you could have a secret named com.foobar.password, and the content of the secret is my secret password, right? So there's nothing technically complex about the secrets themselves. They have a name and a value. And side note, my boss suggests I mention this. In normal development situations, the reason this exists is that in garden variety greenfield projects, or even when you're doing some legacy maintenance, you need to add secret management. This tool makes it possible for you to avoid the typical problem, which is putting passwords and other secret data inside of configuration files, right? Because that's what historically was the easy way to do development. That's highly problematic from a security perspective, and this helps obviate that problem. And I'll show you how. Okay, so basically how they work, you spin up a swarm, you create your Docker machine, you spin it up into swarm mode, okay? And then you create your secret name and content, and you add it to the swarm. You make it available in the file system. I'm sorry, excuse me. It is made available in the file system of the container in the run secrets directory. So you can create a file, a configuration file called Docker Compose, which defines what containers are going to run in the swarm and which of those containers has access to the secret in question. And then when those containers spin up, when they, if you have an application running a container and you tell that application, hey, look at this run secrets directory and look for the name, the file that has this name, and the contents of that file will be the data that you need to whatever it is, the secret that you have. Secrets can be deleted, but not updated, but there is a rotation strategy available. If we have time, I'll get into that. It's been a while since I looked at it, but you can, in one command, delete the named secret. You create the new secret, and then you delete the old one, and at the same time name the new one with the old one's name. And that's how the secret gets rotated. And then Docker automatically restarts the container for you so it sees the new secret, which is kind of cool. Works surprisingly well. Okay, so there's a few different advantages of Docker secrets that are worth noting. Once you add them to a swarm, they're always there. That you don't have to re-add them every time you start the swarm or anything like that, as long as the environment, the hosts haven't changed. You haven't put things onto a new host. You can restart the swarm as needed. The secrets will still be available because they're in the raft logs. They're good for all kinds of things. It doesn't matter whether they're plain text or hex data, or you can use whatever, you can stick whatever you want in there, and they'll persist across restarts, which is also very handy. Okay, so now comes the technically entertaining part of the presentation here. Let me get my terminal up and turn on mirroring. Where's my displays? I'll do it the hard way. Wow, that's small. Can you guys see that okay? I'm going to make it a little bit bigger for me. All right. Okay, and let me blow the font size up a little bit. Can you guys see it okay? Okay. Now I'm gonna have to lean on my script. Actually, is that gonna be the, yeah, I guess this is the easiest way to do this. All right, so I've already set up I'm in my the directory that I want to use for this particular purpose. So first we're gonna start with creating the Docker machine and getting access to it. Whoops. It's now creating the Docker machine on my MacBook that will operate the containers that we create. It takes a couple of minutes because of the actually, I've yet to look through the source code to find out exactly why this particular step takes as long as it does, but it does. Does anyone have any questions so far while we're waiting?
So you mentioned Docker Compose. What's the relationship between Docker Compose and Swarm?
It's changing right now because Docker Compose was used, I think it was originally designed as a deployment solution so you could deploy multiple containers in one fell swoop. Swarms run with, are defined by stacks instead of Docker Compose. But the Docker Compose definition file, the configuration file, and a Docker stack configuration file are very similar. They're structured in almost exactly the same way. But with Swarm, you're explicitly saying, I'm not only spinning up a virtual machine that, I'm not only spinning up a Docker engine that's going to run these hosts, these containers, but I may be spinning up multiple Docker engines across multiple hosts that are all going to run this set of containers. And I haven't gotten too deep into the stack stuff yet because it's relatively new, and I'm not by any stretch of the imagination like the world's leading expert on Docker, but I learned about this Docker secrets thing on my latest project at my latest client. I'm like, this is kind of cool. I bet you other people would find this interesting. Hence, I wrote this up. Okay, so now we've got the Docker machine running. We can see that it's there. It's called secrets testing. We can do an environment check on it, if we can spell. And then now we're going to tie our terminal into the machine, so into the terminal of the Docker machine. So at this point, did I do that right? Oh, no. I forgot eval. Ha ha ha. Thank you. Okay. So now when I check my environmental variables, you notice down at the bottom here, there are all those same Docker variables. Right. Okay, so now we're going to create our little Docker file, which I'm going to copy the contents of because that's easier. Okay, so I'm creating a Dockerfile. If you haven't seen a Dockerfile before, the from line, which is always the first line as far as I know anyway, names the container that's the base layer of your image. And then the command line in this case is just ping localhost. It's a application that will keep running for as long as it doesn't get interrupted. Okay, so now we can build it. Call it my secret image, and we're going to use the local directory. Docker will by default look for the Docker file, pull down whatever layers it needs to build the image, and then put the image in the local, in the repository of choice. In this case, it's the repository that's inside of this Docker machine. So this also takes a couple of minutes. I haven't figured out why it's not caching the way I think that it should be, but I will figure that out between now and the next time around. Any other questions while we're waiting? Yeah.
I guess if you shell into the Docker container itself, would you be able to read what's in the secrets directory?
Yes, indeed, and I will show you how to do that. There's a command called Docker exec that allows you to execute basically command lines inside the shell and get the see the system out in the container. Sorry, I didn't say that very well. Docker exec allows you to send commands to the system in of the container and then read the system out on your command line. Excuse me. Next time I'll also pick a lighter weight image. Okay, so now that is built. If we do Docker images, we can see that my secret image is now available. It also pulled down Ubuntu as the base image, and it's ready to go. So we can now create our swarm. Normally at this point you might do Docker run my secret image, but we're creating this as a service. One of the tricks with Docker secrets is you cannot add them to individual containers or engines. The Docker engine has to be running in swarm mode in order for it to accept secrets. Okay. Well, that's right. Okay, and that's it. That takes nearly no time. And now we're going to create our secret. Are there any Secret Show devotees in the audience by any chance? Great program, very funny. This is the content of our secret. And now we can create it as a secret. Is it? So here we're creating a secret that we're calling my secret name, and the data that it will contain is in the my secret name file. So it will read that file and suck the content in to the swarm, give it the name my secret name, and the contents of that file will be what the content of that secret is. And it comes with this nifty identifier that's randomly generated, I presume. We can see that the secret is there now because there's something responding to the secret command when we ask for a list. We can, I think it's inspect my secret name. And this tells you what Docker knows about the secret without revealing the content of the secret itself. So it gives you the unique ID within the Docker system as well as the name of the secret and other data that's available about it. Does anybody know what the proper use of the labels field is? By the way, I've seen how to add things to it and to remove things, but I don't actually know how it's used. Okay. Oh yeah, you can. It's basically a
Arbitrary metadata that you can use to then manage the objects.
Okay, that would make sense. Cool. All right, so we've got our secret now in the swarm. Oh, wait, do we? No, I created the secret, yes. Now we're going to create the service. So now the Docker machine has taken the MySecret image, pulled it down, instantiated it in the swarm, and now it is running inside of the swarm. So if we do Docker PS, you can see that it's running here. Oh yeah, forgot the Docker service ls. I think that's the same thing. No, that's the service. Okay. Okay, and now, all right, so the Docker service ls is what gives us the container. I'm sorry, the Docker PS gives us the container ID, and that's what we need to see what's going on inside the container. So we're going to do an exec, if I recall correctly, IT, yeah, IT. The name of the container, and ls run secrets. Now you can see that the secret is there as we added it. And then we can do the same thing, except there you go. So when you write an application that needs to see the secret, you can tell your application, go to run secrets, my secret name, and read the contents of that file, and you'll have access to the secret for whatever purpose you need. So for example, in my current project, one of the ways that we leverage this tool is we have to leverage some existing LDAP accounts that are managed outside of our control, and periodically the passwords change. So we're using this as a means of storing those passwords. Now, from an enterprise perspective, this is somewhat suboptimal. If you're going to run an enterprise class software solution like what our client should be thinking is the correct thing to do, you should really have HiPAM or a hardware module that manages all of your secrets for the company in one place. That way you can minimize your, what do you call it, attack surface, and maximize your control over the secrets. But when you're working early on in development, or you don't have access to that kind of thing, this beats the pants off of having the stuff in garden variety, configuration files in your source repository, that kind of thing. Make sense so far? Okay. The other thing worth noting about Docker secrets is you can create another secret. Oop, except I forgot this. Oh, not that. Secrets testing. Is that it? I don't remember. I think I'm missing a couple of lines here. This is where I ran out of time last night. I was going to show you guys the rotation bit, but I don't remember off the top of my head what the commands are. I have to look it up. All right. Does anybody have any questions before I move on from the CLI bit? Yeah.
What's the benefits of using this secret inside the swarm rather than like environment variables that are managed by like DTOS or Kubernetes or something else?
It comes built in. So it's something you don't have to add any other functionality. It comes built into Docker. But outside of that, I mean, you really shouldn't be using it in a business environment long term. But in the short term, it's a reasonable solution. If you've got an outside management tool, it's hard to say whether it's better. But it's at least convenient and relatively easy to understand. Anyone else? Okay. Go back to no, that's not what I wanted. There we go. Okay. All right, so there are some limitations to Docker secrets. You're limited to 500 kilobytes of data, which doesn't sound like much, but if all you're storing is things like certificates or passwords, that's ordinarily plenty. And that may change down the road as Docker evolves this particular product. I don't know. I haven't seen any release schedules for it yet, so I don't know exactly what they have planned. As I mentioned previously, it's only accessible from within Swarm. You can't just run a Docker machine with a Docker container and make it available that way. That would be too simple. You need to make it available to your services so that any container of the right flavor can see it. That way, that's what allows you to distribute the load properly. And there's some limitations in Windows in particular. At least this is according to the latest documentation. This may have changed, but the raft logs by default are not encrypted in Windows, if I'm not mistaken. So you want to use a tool like BitLocker to encrypt the drive, which solves that problem. Sorry, secrets of persistent and clear text containers root disk. So while the service is running, they're exposed in memory, at least to a certain extent. And then only administrators on the system can see them, so that you have to run your containers with a user with the appropriate level of rights to be able to access this stuff. And there are some other considerations. You can use, as I mentioned before, Docker Compose. This is a little snippet from a Compose file that to expose secrets to particular containers. So for example, you can see that we have we're defining a secret called DB password here, the contents of which is defined in this text file. And then we're exposing that secret to the WordPress container by telling it, hey, you have access to this secret, it's called this, so when you look in your run secrets directory, you're going to see this file there. Secrets are persisted across restarts of of Docker machine and of the system in general. If you restart your host, you'll still be able to access them because they're in the RAF log. When the service restarts, it can pull the secrets that it previously had available. But if you redeploy to a new set of hosts in new Docker machines, you will probably have to manually re-add the secrets following the procedure that we just did. And you can lock the swarm, but there are serious downsides to doing that. So I think the usability aspects of locking it costs too much. Personally, I think they should come up with a simpler solution for this. But you can, once you create a swarm, you can lock it and then you need to keep those keys in a separate location because you're going to need them to restart the swarm. And that's another way of adding an extra layer of security on top of your secrets. So, wow, good timing. That's about what I've got. Thank you all for coming. Does anybody have any other questions about secrets and swarms and Docker and all this fabulous stuff? It's pretty straightforward. I know it wasn't exactly a deep dive, but I'm happy to, if anybody has any follow-up questions, you can find me by email and Twitter, billhorvath.com, as well as my personal site. So thank you for coming.